Let us prove that the limit of a sum of two functions as x approaches to any c is equal to the sum of their individual limits. In the statement, it looks like this. If the limit of f or f of x as x approaches to c is equal to L, and the limit of g or g of x as x approaches to c is equal to m, then the limit of the sum of the two functions as x approaches the same value of c is equal to the sum of L and m. So we are going to use here a definition of the limit to prove whether this is true or not. Take note that if we are going to prove this using definition of limit, we are going to first assume we're going to assume a certain epsilon greater than 0 and look for an existence of a certain delta. Once we can establish a certain delta, then we can really move forward to our intended target. I'm not going to write here anymore the definition of the limit. I'm going to proceed immediately to the proof of this. So please bear with me. Of course, we will start with let epsilon be greater than 0. What we need to do here is we need to show that there exists a certain delta greater than 0 such that for all x element of A, if the distance between x and c is greater than 0 but less than that said delta, then we'll be targeting this, the notation or difference of this, f of x plus g of x minus the sum of their limits must be less than epsilon itself. Okay, so this is our intended target, but first we will be looking for an existence of a delta in order for us to capture this method. Now, before we proceed into that, there is an important scratch work here, not necessarily scratch work, a portion of the proof that will guide us later on. I would like to add it here. Take note that the scratch work I'm telling you here is just a simple, what they call this one, simplified form of this expression. So it will be guided later on whatever target you would like for our delta and our epsilon. So take note that if we have here f of x plus g of x less the sum of L and m, this is actually equal to, we'll have here f of x, regrouping this one here, minus L, okay, plus you will have here g of x minus m. I would like to start with this, so again I will be guided with what would be our intended delta and epsilon. According to triangle inequality, this is less than or equal to separating them into different what they call this one forms, plus you will have here g of x minus m. Let's end to this, and we will be returning to that later. Just a show of the simplified process of that. Then we go to the claim. Since the limit of f of x as x approaches to c is equal to L, then for any epsilon sub 1 greater than 0, there exists delta sub 1, it's still delta sub 1, greater than 0, such that if the distance between x and c is greater than 0 but less than delta sub 1, and x is an element of A, then we can say that f of x minus L is less than epsilon sub 1. Okay, so we have structured this now. Also, the limit of g of x as x approaches to c is equal to m, then for any epsilon over 2 greater than 0, there exists delta sub 2, this is now sub 2, greater than 0, such that if the distance between x and c is greater than 0 but less than delta sub 2, and same, x is an element of A, then the absolute value of g of x minus m is less than epsilon sub 2. Okay, now with this in mind, take note of these notations these are the quantities needed here for our scratch work. We consider it to be scratch work earlier. So we need to come up with a representation that when we combine them, we will result to a certain epsilon, because this is what we need here. Okay, so that's what we want. So we are going to let here epsilon sub 1 for this be equal to epsilon over 2, and epsilon sub 2 also epsilon over 2, so that they, when they will be added later on, they will result into a certain epsilon. Okay, so after that, also we are going to express the existence of delta, and since these are all both delta sub 1 and delta sub 2, we could have here let delta be equal to the minimum of delta sub 1 and delta sub 2. Whatever be the minimum of that, that would correspond to our delta, which are both what they call this one, whatever the minimum, still greater than our x minus c for both situations here. So with that, since the delta is now existing, then we can say here, if the distance of x minus c is greater than 0 but less than delta now, okay, whichever would be the delta, at least we have shown that existence of that delta, we have, so we can now go back to the take note portion earlier. Okay, so we'll have here f of x plus g of x minus the sum of L and M, which was again represented by this triangle inequality. No need to write this middle portion automatically with the last. We'll have here by triangle inequality f of x minus L plus g of x minus M. Then we were able to emphasize them earlier. This is less than, greater than epsilon sub 1, epsilon sub 1 is greater than that, and epsilon sub 2 is greater than that, which we were able to denote is to this. So this is greater than epsilon sub 1 plus epsilon sub 2, which is represented by epsilon over 2 plus epsilon over 2, which is equal to simply epsilon. So with this, hence, we have this form. Hopefully I still have some space. Hence, we have here f of x plus g of x minus L plus M is less than epsilon. Okay, so we have established this now. Okay, with that, the final statement, since epsilon is greater than 0, is arbitrary. Okay, then we conclude that the limit of the sum of f and g as x approaches to c is equal to the sum of L, that's L, and M, because we have established this already as part of the definition of our limit. So we're just going to do something like this and duplicate if we have similar situations. Probably in the next video we'll talk about subtraction, then multiplication, and probably we're going to duplicate this process starting with these take notes that we will be guided on what will be the assumption or the assumed value for each of the limits. Thank you very much for watching.